Hello everyone, in today's class we're going to go through the first lesson of fluid mechanics. We're going to look at what is a fluid. So the definition of a fluid is it's a substance that deforms continuously when shear stress is applied. Meaning, so for example, if you apply a force on a copper plate, okay, let's draw this out. This is your copper plate. Okay, if you apply a force to that, what would happen is that the copper will deform a little bit, then it'll push back, and the shape of the copper will change from this first schematic here to the second one. Okay, whereas if you apply a force, a significantly smaller force to a body of water, what would end up happening is the water will deform continuously and lose its form. You can see that, for example, in a swimming pool, when you put your hand in the water body, what would end up happening is your hand will go in, penetrate the water, and the water will not push back. So that's the definition of fluid. It applies to liquid and gases. Okay, for the unit system we'll be using, we'll use SI and also British gravitational or imperial, which is mainly used in the US. It's good to have because some of the pipes or machinery are manufactured in the US, so you need to be familiar with both the unit systems. For length, SI we use meters, mass use kg, and force we'll use Newton for SI. For British gravitational or imperial, length we use feet, mass use slugs. Slug is 32 pounds, and for force we use pounds. Okay, so that's for the units system. There's also important properties you need to know for this course. Some of these properties are, one of these properties is density, which is basically how much mass is in a unit volume, which is mass over volume. With SI units, that will have units of kg per meter cubed, whereas for imperial it'll be slugs per cubic feet. Okay, another main property is specific weight. Gamma equals, which is basically weight over volume. Okay, specific gravity is a ratio used to compare the specific weight of a certain substance with the specific weight of water at 4 Celsius or 39 Fahrenheit. It's also equal to the density of a certain ratio of a certain substance over the density of water at 4 Celsius. So specific gravity is basically a ratio that relates a density of a substance with the density of water, and the specific weight of a substance with the specific weight of water. Another main equation you need to know is the ideal gas equation, which you probably saw in physics. Most of these properties, you went through them in physics or thermo. For the ideal gas, it's PV equals nRT. It can also be written as P over density equals RT, which we will use later on in the course. The final property is viscosity. Now there's two types of viscosity. The real viscosity, which is the absolute, symboled as mu. Absolute viscosity. Whenever you're asked to find the viscosity, the absolute viscosity is meant. You're asked to find the absolute viscosity. Unless specified, find the kinematic. Viscosity. Okay, so the kinematic viscosity, this is the equation for it. Equals the absolute viscosity mu over density. This ratio will be used on later on in the course, whereas the absolute viscosity mu, we'll use this equation to find it, which is shear stress equals viscosity times the velocity gradient, du dy. This here is your velocity gradient. That's your absolute viscosity. Okay. And that's shear stress. Viscosity has a units of newtons, seconds, length squared. Okay, if you can't memorize this unit, what I insist you to do is to drive the units. Basically look at, hey, shear stress is force over area, which is force over length squared, or newtons. This can be in newtons, or if you're using US units, imperial units, it will be pounds. Okay, the velocity gradient has units of, du has units of length over time, dy has units of L, length. Therefore mu viscosity will be force times time over length squared. So you don't have to memorize the units, you can drive your way to find it. Okay, now if we plot a graph comparing the shear stress results with given du dy, given a given velocity gradient, we'll notice that air has a lower relationship. Okay, meaning that you'll need less shear stress to obtain these this velocity gradient, whereas water has a slightly higher relationship and oil has the highest. Again, these are Newtonian fluids. Which means basically they have a linear relation, shear stress and velocity gradient relationship. Okay, whereas there's other fluids that don't have a linear relationship, such as toothpaste, paint, and so on. The relationship is more like a curve, like this. This could be toothpaste, and so on. So that's it for this class. See you in the next one. We're gonna go over pressure.